himself talk about. But actually, also without knowing the actual term and what entails DataOps, they started just applying methodologies that can be connected in some ways to DataOps. Wow, let's get started. So actually, that's the problem that we saw with Tango. That people, they want to become data-driven. They know they're sitting on a huge amount of data that have no way to get started. And that's why we need help, and everybody needs help in this. There needs to be methodologies in place, there needs to be processes, there need to be tools and technologies, and just also a guided structure and on how to become data-driven. What does it mean for you as a company? Because it's always going to be use case specific. It's always going to be custom. Whatever application that you're going to build, don't believe the guys who say, I have the solution that fits them all. It doesn't exist in data. Everything is so different. The data models that you use, the algorithm that you have to use, the things that you need to set up, it's always going to be something else. Always the same flavor of things, but actually the implementation is going to be something else. Now, first question. What I like to know is, we had the first DataOps meet with Peter, and I want to know the crowd actually. So who are you? What type of data scientist, data engineer, data analyst are you? Or in fact, more like, what do you think you are? And because it's always something different. It's not because you think that you're data scientist that you actually are doing data science. And you can easily be more like a data engineer. So we have just categorized it in 5 personas. The data scientist, what I like to think about data scientist is that guy or girl that's going to make the algorithms, the machine learning stuff, the models. That's something I pinpoint to a data scientist actually. The business analyst, they use the data and the models created by data scientists to just get more like business intel out of it, like a marketing person, C-level, and they need reporting. The reports are going to the data, driving the reports are going to be provided by a data scientist, but they're actually the analysts. They have to interpret the data. So then a data architect is something like somebody like me. I like to just see all the connections between everything. Yeah? And that is, if you have real-time requirements, then I know how to kind of create those type of data flows to become a real-time data-driven company. If you need that type of data structure, if you need that type of data technology, data storage and stuff like that, I know quite a lot of different technologies, so I know how to interconnect them. That's my job as a data architect, actually, is seeing the connections in between everything, creating data flows. How can you do this? Data engineer is going to do the heavy lifting, actually. He's going to set up a cluster, the Spark cluster, the Hadoop, all those data stores. That's the job of data engineer, the actual stuff. Because without things running, actually, we can't do anything. And data scientists, they can just try to create models, but if there's no data flowing in their models, then nothing is going to show up. The data enthusiast, there's somebody in a company actually that likes to try something with Python, or likes to try something with whatever BI tool you have, and likes to try to just play with data, because they have a sense that data is becoming more and more interesting. And actually, if you're a marketeer, or if you're a salesperson, or if you just do stock management, CRM stuff, everybody can be a data scientist actually, or at least a data enthusiast, and start just digging into whatever type of data that you can get your hands on. That's a data enthusiast. So who thinks of himself that he's more like a data scientist? And show of hands. So 3 people, right? The business analyst. So the end user of the data. Oh, 2 people, all right? Cool. Data architects, guys like me. It's funny, they like the CTOs or the data architects. Data engineers, the guys who do the stuff. So 1, 2, 3. I'm kind of. Sometimes I'm also a data engineer because just it doesn't matter if you draw a perfect picture of a data architecture. If it doesn't work, you have to just try it yourself, see whatever things can happen. Data enthusiasts? Then listen then. Okay, nice. Welcome everybody. So, like I've said, there are 5 personas, at least 5 personas. And that's big categories. You can see many more differences between everybody. And the problem with this entire ecosystem is that actually everybody needs something else. Everybody wants something else. Everybody uses a different type of tool. Everybody sees at data in their own kind of a different way. And DataOps, first thing, they try to just create methodologies where everybody can feel happy. Everybody has somewhere to look to and somewhere to play with. If you're a data scientist, biggest thing that you can come across is, I know all the data scientists that just like to work with big and huge CSV files. But of course, where can you drop those CSV files? You need like an infrastructure to have those CSV files ready for you. Of course, if there's no data pumping into the CSV files, you have not much to work with. If you want to do more, do like batch processing. Some use cases don't allow batch processing for the data scientist. And then you have to have your data architect and your data engineer working close together with the data scientist, and to just talk with each other. Okay, this type of a business case, this type of use case, we can't solve it with just huge CSV files. We have to do something else. Second struggle. Yeah, how to become data driven? What does it mean for you? For everyone, it's going to be something else. Okay? I can imagine C-level asking to their data scientists or newly hired data scientists, because in Belgium often it's this way. We know as a company we have to do something with data. We just hire a bunch of data scientists. Get started. Okay, first question. What do we have to do? Okay, I like to know this and this and this about our company. How are our sales, or what is our most sold product in April, in whatever type of use case. Okay, the mission is clear. Where can I get data? It's scattered all over around a company, usually, especially in Belgium. It's so strange whatever you see in companies. I've did a small workshop together with Fortis. The people, the business analysts, they knew actually that, okay, if we can have that type of information, that type of data, that type of stuff, all connected together, and we can do our work much better. But the guys on top, the C-level, they didn't understand it. Because actually it wasn't structured well enough, because you had corporate Fortis. You had the leasing company, the leasing branch of Fortis, then you have the other type of banking stuff in Fortis, and everybody was an island on its own. There were no data flows interconnecting the things. So nobody could get data whenever they needed it, actually. And that's also a problem. It's a huge problem. And that's also something DataOps tries to just make people aware of. And you need to have data, you need to have availability of the data. It doesn't mean that you have to know the most recent stuff. And you can go on a long way with no data. So you don't have to just jeopardize production, actually. And the other point is, how can we do stuff? What type of model do we use? That's a question the data scientist asks. A data analyst, what type of visualization tool can I use? BI tools, stuff like that. How can I best visualize this trend and that trend? How can I just make the best graphs to just show things to me? That's a data analyst worry. As a data engineer, okay, what type of data store can I use? What type of a real-time system? Kafka, all the technologies. There's a bunch of technologies floating around. It's such a jungle of just everything is all around it. Some things are starting to crystallize, luckily. It's taken like 10 years. Hadoop is out of the picture, for instance. It's used as a shared file system now. But you don't do MapReduce anymore. And everything is now, if you want to do stuff like that, you go to Spark and then you start over. And because those type of technologies are here to stay. But still, for the data store in itself, there are like 450 relevant data stores floating around. Everything with their specific means, specific type of thing that they're good at. And how can you just try it out, everything? It's impossible. And especially when there's somebody just looking at your back. Is it done yet? Is it done yet? Can I see something? Can you present that data? Can I have the report now? No, I still am structuring things. I'm still working on the model. The data that I'm going to show is not correct still, but everybody wants it yesterday. Yeah. Second slide. Now, data science is still something magic, especially when we talk about big data. I always find it funny that you have like petabytes of information. Then you run it through a model, and then something magical comes out, and you can predict that or whatever use case that you have. But is it correct? Who's going to tell? Yeah, that's another problem, and especially it's in all the different categories. If you're like a data engineer, correctness means something else for you. If again that Spark cluster is failing or one of the workers is failing and dropping down, why is it happening always? Why is it happening at that point? If your Kubernetes cluster drops a couple of containers, why is it happening? That's a problem for the data engineer. As a data architect, you don't want to make the same mistake over and over again, so you need to validate the things that you draw out and set up real time. Can I really do stuff in real time? Or is near real time good enough for the use case? Those are problems that you have to think about. Then correctness as well for the data scientist. Which model do you use? If you see strange thing happening at the end in the data, in the graphs, was your model incorrect? Or was the data incorrect? Or was the way that you get provided by data, was that incorrect? So at every point, at every step in the entire ecosystem, things can happen. And that's also something DataOps tries to just minimize. And they try to minimize the worries about this type of stuff. Because it simply should work. And then if it works, if the fundamentals, if the base is good, is correct, then you can immediately start with the models, with data cleanup, potentially, with getting insights out of your data, and making that nice reporting so C-level is happy. Now, fourth struggle. That's actually about the flexibility, because at this point, C-level wants something. Tomorrow we need something else. At this point, we started with a certain model as a data scientist. You see that it doesn't fit well. You have to change that. If that means changing the model, also changing how data is provided to it, then you have to talk to your architects and to the data engineers. Change things. Be flexible. But in the current structures, it's not always this case. It's not always possible. Because people still are afraid to do stuff on production. And usually it's a good thing to just stop funneling with production, because if it's broken, don't try to do something with it, don't duct tape stuff, don't try to fix it. It does its job at this point. But know that in a far future or not so far future, you're going to have to make changes. And it shouldn't scare you actually. It shouldn't be, a data scientist shouldn't be afraid to just try out a new model. A data engineer shouldn't be afraid to just put in place an entire new data store and try it out to see whether it fits our purpose as a company, as a project much better. People shouldn't be afraid to even do this type of stuff in production. But in order to get there, to get to that point, we need to have methodologies in place. We need to have structure. We need to have guidance and the correct tools. And actually what DataOps is about for us. providing those methodologies, providing those type of tools, say, going to a company and say, okay, you have this type of problem, you have this set of tools that you can use. If you use them well, and we can help you just using them well, other experts can do that as well. We guarantee that you can be flexible. If things change, we can guarantee that you can change with them, that you can just live in this ever-changing world. Luckily, Gartner has put it on the hype cycle. That's why it's now becoming and getting more traction, because DataOps, or the idea of DataOps, has been there quite a while, but nobody was talking about it like it's DataOps. And even what you can see and hear in the next talks, they weren't aware they were doing DataOps as well. It's no problem. It's all about providing the necessary structure from the start on. And that's what a lot of people just forget. Gartner has put it just at the beginning of the hype cycle, so we still have some time, especially as a company, trying to make money out of DataOps. We still have like 2 years to just reach this point, and everybody is disappointed about the entire DataOps meeting. So we better get it correct immediately, so that we just funnel into this side of the graph as well. So for us, DataOps is all about everybody becoming a data professional. Yeah? In order to get there, it's methodologies. We need to have structure. We need to provide people with the right tools and technologies. Not just letting them loose, because that's not what happens. If you want to do data science, okay, pick and choose this wide variety of technologies. If you have chosen the wrong one, okay, yeah, sorry. Start all over again. Go to your boss and say we need more money because we picked the wrong one. We need to do it all over again. Get help from experts. And it doesn't mean get help from consultants or whatever. In a lot of big teams, and that's what Jorik is hopefully going to talk about, there are a lot of knowledgeable people already in your teams. But usually, if you want to do a data science project, you only put together the old way, in fact, you only put together data scientists. But they don't know how to manage a cluster. They don't know anything about it. So immediately make teams of data engineers, data architects, DevOps guys, bring them together, let them talk continuously. And then everything is going to be set up right. And they're going to get much faster, much further. Fourth point, feel empowered. Just try out your data. Work with it. Don't be afraid to change and dare to fail. That's all what's DataOps. Alright. I hope I've given some type of an overview of DataOps and what it can mean for you as a company, especially if you want to become data driven. Thanks a lot. We have some small survey ready. Please try to fill it in if you like to, at the end of all the other tasks. While Daphne is handing out stuff, we can set up the next speaker, Jorik. So as I mentioned, he's the cloud engineer of Team Leader, and they're now doing a very incredible, actually, data project at Team Leader. And it's nice that they start at this point already, because we know for bigger corporations, they still haven't started with that type of thing. Right, the floor is yours, Jorik. And if there are questions, feel free just to ask or afterwards.
I had a question.
Yeah.
So you had the 5 personas like people working with data. You consider them all involved in DataOps?
Yeah.
So it's
this should be all involved. Yeah.
Right.
It's always going to be a team effort.
Yeah.
Yeah. You can't do it by yourself.
There's not like a DataOps. A DataOps is a team.
Well, if you find that person that can do everything, send them to us. We can hire. But they don't exist, unfortunately.